The prairie is not a land flat and unbecoming, but a land fruitful of possibilities. It is the foundation of our existence for many centuries to come. The prairie is the game board on which the skies above influence the land and the future of its people.
Illinois Skies is a quarterly magazine that features stories about the skies and landscapes of Illinois, the Midwest, the nation, and the world.
You may not realize it, but this is a story about you, the resident of the Illinois landscape.
Whether your family has been here for generations or just moved from another region, your story was and continues to be shaped by the environment.
As little ones, we have looked up at the sky and thought with our imagination about these animals or creatures, and they became visible to us. But their true identity comes from an amateur meteorologist from the early 1800s. What are those puffy things up in the sky?
Storm systems bring us either a little precipitation or a surplus of precipitation. Which storm tracks influence our skies here in Illinois?
While some of those storms track across Illinois, there are some seasons when the storm track simply misses us altogether, pushing us into a drought. Although we are not in a drought this season, California has suffered an exceptional drought. Cameron and Nate Page traveled to Fresno, California to research the effect drought has had on their region.
And finally, we have heard many terms thrown around this winter season, but one has dominated the media: polar vortex. The phrase is truly scientific, but somewhere along the multitude of stories we have heard this season, it has become confusing. We will define in an easy way what the phrase means here on Illinois Skies.
University Department of Geology-Geography is a proud sponsor of Illinois Skies and provides integrative learning opportunities for students and the community to explore the physical and cultural world near and far.
Chris, when I was young, I used to lie on the ground staring at the sky. My imagination swirled with images of animals of all sorts, or even a human's head with a big nose.
Does your imagination still run wild when you look up and see clouds like that in the sky?
I have to concentrate really hard because I know what those clouds are after many years of teaching clouds to students. Although we all see clouds as different things, one thing is for sure: they all have specific scientific names created in the early 19th century by one man, Luke Howard.
In 1804, Luke Howard, an amateur meteorologist from England, developed a classification scheme based on the appearance of the cloud formation. There are essentially three basic cloud forms: stratiform, cumuliform, and cirrus. These forms are defined from the Latin terms that describes their appearance in the sky. For example, stratus in Latin is translated as layered. Clouds that exhibit a layering effect will contain the root stratus. Cumuliform describes the cloud's appearance as being stacked. And finally, cirrus clouds are defined as hair-like. There are three cloud types that are similar to the basic cloud forms. However, their added features give them a separate definition. Clouds that have precipitation are given the Latin prefix nimbo or the suffix nimbus. For cumulus clouds that have vertical extent and have precipitation, they are labeled as cumulonimbus. Stratus clouds that have precipitation are called nimbostratus. Each cloud type is categorized according to the basic form: very low to high altitude. Learning the different cloud types is relatively easy if you notice the patterns, size, and height. It is important to remember that these are basic cloud types, and it is possible that nature can provide several different cloud combinations within a single day or even hour. Stratus clouds exhibit a layered appearance due to the gradual incline of relatively weak winds associated with an oncoming warm front. As the wind blows, cloud droplets are spread across the sky, giving a layered appearance. Stratus clouds are typical of the stratiform definition, layered, at the low altitude. It is the cloud that provides for a gloomy day. Altostratus clouds are found within the middle altitude. When the sun shines behind this cloud, the cloud appears milky and fibrous. Cirrostratus clouds are found in the higher altitudes. A halo around the sun or moon can be used to identify this cloud. This cloud is mostly made of ice crystals and gives the appearance of a very thin film with the disk of the sun or moon extremely distinct. Cumulus clouds are just as they are defined, large, white puffy clouds. These clouds are typical of a fair weather day. Altocumulus clouds are smaller than cumulus and often positioned in rows. These clouds can often display a mackerel sky. Cirrocumulus clouds are the smallest of this class of cloud and arrange themselves in rows in the higher altitudes. Cirrus clouds, defined as hair-like, are clouds that exhibit a streakiness as if they were pulled apart like cotton candy. There is only one cloud associated with this form, which is the only one found in the higher altitudes. Nimbostratus clouds are clouds that look like the stratus cloud, but they produce precipitation. This cloud is found in the very low altitudes. The only cloud that extends from the low altitude to the high altitude is considered the king of all clouds, the cumulonimbus. This cloud often exhibits an anvil top and produces thunderstorms. Meteorologists and weather enthusiasts use cloud classification to understand how the immediate atmospheric environment is evolving and can determine a general forecast. For example, stratiform clouds are commonly associated with an oncoming warm front. If you see cirrostratus clouds and then altostratus and then stratus move in, you can generally expect warmer temperatures and a chance of rain showers in the next few hours. When the region experiences thunderstorms ahead of a cold front, you can generally expect cooler temperatures and clear skies with a few cirrus clouds the next day. Clouds are a great tool in forming a basic forecast of what is to come. The next time you need the forecast, look up at the sky and read what the clouds are telling you. In most cases, you'll be correct.
We have heard the term Alberta Clipper, or simply Clipper. What does it mean? While storm tracks take different paths across the eastern United States, each one has a unique character based on speed of development and the amount of moisture available. Chris takes us on a journey of 3 major storm tracks that influence Illinois skies.
Storm tracks are the routes that storm systems travel upon from the Rockies to the Atlantic Ocean. The speed of these tracks depends upon the amount of moisture available to them from a major water source such as the Gulf of Mexico. The closer the track is to one of these large bodies of water, the slower it moves. Consider this simple example. If you picked up 2 empty 5-gallon buckets, how fast could you run? Now try to do the same thing, only with 2 5-gallon buckets full of water, each weighing roughly 40 pounds. How fast could you run now? You guessed it, much slower. From this simple example, a storm system that tracks furthest away from a source of water will develop and move quickly, while a storm system closer to the Gulf of Mexico, a major source of atmospheric moisture, will develop and move much, much slower. Let's start with the storm track that is furthest from the Gulf of Mexico, which develops quickly and moves fast, the Alberta Clipper. Clippers are born in southern Canada, hence the use of Alberta in their name, and travel through the Great Lakes and continue on towards the northeast. Clippers are typically known for their fast movement due to their lack of moisture, those empty 5-gallon buckets. Winds and a lack of significant snowfall are characteristic of this type of storm system. As we move south, closer to the Gulf of Mexico, the next storm track originates over the central Rockies and is called the Colorado Low. This track typically heads through Illinois and Indiana and exits through the northeastern U.S. The speed of development is slightly slower than the Alberta Clipper because it is closer to the Gulf of Mexico, sort of like trying to run with half-full 5-gallon buckets. You've slowed down, but you're still jogging. The last storm track originates in the Four Corners region of the Southwest. The inside leader migrates through Texas and the Gulf states of Mississippi and Alabama before turning northeast and moving up along the eastern seaboard. This storm system has an abundance of available moisture due to its proximity to the Gulf, which causes it to migrate along its track very, very slowly. Now, as winter turns to spring and the last of the Alberta Clippers hurriedly make their way across our country's northern tier, we begin to move towards the warmer months of summer. Hopefully, the days of looking to the north and west for our next snowfall or to the south and west for our next ice storm have ended. With summer lying ahead, we'll begin our transition into thunderstorm season, the oppressive heat and humidity brought in by the Colorado lows, and the relief that's ultimately felt as the storms pass and cool, crisp air from the northwest settles in.
Every once in a while, we need a moment to reflect on the day and let the hustle and bustle melt away with images of the Illinoisan landscape and original music. As we say goodbye to the long winter season, let spring burst forth with a multitude of colors.
Drought here in the Midwest can be a serious matter when it comes to agriculture and sometimes even water supply. But in California, they have a serious situation when a regulatory drought is declared. Cameron and Nate Page traveled to Fresno, California to learn about the effects of drought on a region different from our own here in central Illinois. Nate will join us afterwards to highlight some of their research and what they found.
Fresno County is the #1 agricultural county in the nation. And so most people don't realize that when they sit down to dinner in the evening, if they're having a slice of pizza, more than likely that tomato sauce originated here. Processing tomatoes are the #1 product that's grown right here.
Fresno County is situated on a vast flat landscape between the Sierra Nevada mountains and the coastal mountains of California. Considered the largest agricultural county in the United States, it is also prone to significant drought. Since January 2012, the Central Valley has experienced drought conditions and has been classified in the exceptional drought category since the summer of 2013. Although the current drought is brought on by the lack of significant precipitation, the government has imposed a regulatory drought on the region.
This is the third dry winter in a row, but we also have regulatory restrictions in place that limit the amount of water that can be pumped into the reservoirs that will then be used for farming as it gets drier and warmer, and typically that water would then be used for agricultural purposes. That is not occurring. The replenishing of the reservoirs hasn't been able to occur in a full capacity for a number of years. In fact, it continues to decline to the point that this year we are at a 0% water allocation.
The Delta region, located just east of San Francisco Bay, is home to numerous species of smelt and salmon. Dwindling water from lakes and reservoirs, which typically keep waterways full, are unable to continue to adequately supply water to the Delta due to the meteorological drought. In order to protect the struggling species, water from the Delta is not being pumped south to the Central Valley.
And so we have to back up a bit. Our water supply originates up in Northern California, where it's historically wetter. And so that water then is brought down through the Delta, which is in the central part of the state of California. And if the water is not captured, it then flows out underneath the Golden Gate Bridge out to the ocean. But the project was put into place to capture that water and then to utilize it by moving it into a pumping system that pumps into reservoirs that would then fulfill the State Water Project or the Central Valley Project, which is the federal project. And then that water fills the reservoirs during the wet months, only when there's excess water in place. And then that water is there available for use by growers as we move into some of the warmer, drier months of the year. But because we have biological opinions protecting fish species, currently the biological opinions have been prohibiting and diminishing the amount of water that's able to be pumped into reservoirs. And so what's happening is it's becoming a battle between the users, between the fish species that need water and also municipal communities and agriculture that need water.
When water is cut off for farmers and the lack of precipitation does not promote a healthy fish population, problems begin to emerge and end up in the courtrooms in order to determine how to essentially divide a non-existent water supply.
For the first time in the history of the two projects, both the State Water Project and the Central Valley Project are at 0. And so it's hard to give any more to a fish species when you're at a 0%, and yet the fish species aren't rebounding and they're not staying healthy. So then you have to look at other things and think, gosh, could there possibly be other stressors that are influencing the decline of the Delta?
Fresno County has always been known for its agriculture. Many generations have worked the land their ancestors established back as far as the late 1800s. If farmers are unable to receive more water for the upcoming growing season, the ignition switch on tractors and crop trucks may have to be permanently kept off. Unemployment rates will rise as long as the zero water allocation ruling continues to be supported by the courts.
The farmers that we have on the west side, or usually in this area, are multi-generational farmers. They've been doing this for 3-4 generations, and they are raising the 5th generation that will continue on the farming operation. But the one component that we don't have and are assured of having is water supply.
I'm joined now by Nate, Paige, and Cameron. What an interesting situation this has been out in the Central Valley region of California. How might this drought situation affect us here in Illinois?
Well, to answer that question, we first have to look at how we went into this project. And we went into this project thinking that this was just a natural-made drought. Mm-hmm. And what we learned was it's not just natural-made, this is man-made. And farmers in California aren't going to be receiving any water from the national government or from the state of California. And that's going to affect us because they're the largest agricultural district in the nation. Mm-hmm. And what this means is that we could see tomatoes, pistachios, almonds, almost anything we consume here jump up not just cents a pound, we're talking like dollars a pound here. And it's going to be very big here in the Midwest.
And I've also heard, Cameron, that you're taking not only Nate, but a few other students back out to the Central Valley later on this spring.
That's right. The project is called Expedition Endurance, and Nate and I are taking 3 other students from the university. And we're going to New Mexico, Arizona, Southern California, Colorado, Utah. and venturing around and talking to water people and researching the water resources and relate them here in the Midwest.
Thank you.
Climate plays an important role in the function of the life on Earth. Animals are naturally designed to live in certain climate regions of the world. Take a look at these two fox. Which one is more adapted to the polar climate? If you chose the one with smaller ears, you are correct. The ears of a fox determine its natural habitat. The ears are either heaters or air conditioners. Smaller ears retain heat, while larger ears allow heat to escape if they live in the desert region. Here's a question to ponder. What about human ears?
We have heard it throughout the winter season.
Polar vortex, the plunge of cold air from the Arctic region. Some think that it is a new phrase created just this year.
But in fact, it is a scientific term that has been around for many years, and it has occurred many times.
In simple terms, we take you behind the scenes of the infamous polar vortex.
This winter we experienced several harsh cold spells, dropping daytime highs into the single digits, and in a couple of cases, the daytime highs only reached as high as the negative single digits. The culprit behind these brutal events was the sudden burst of cold air that escaped the cyclonic flow called the polar vortex.
It's a circulation around the North Pole. In the wintertime, it typically is located around the North Pole. It's a very fast-moving cyclonic flow, counterclockwise flow. And it normally, because of its high rate of speed, it keeps the Arctic air basically from the Arctic Circle to the North Pole. Keeps it continental Arctic air, very cold, very dry. Every once in a while, that polar vortex drifts to the south through Canada, and may go as far south as maybe Hudson Bay, just to the west of Hudson Bay. When that occurs, then that counterclockwise circulation takes the Arctic air that normally hangs out at the North Pole, and then drags it south. And that circulation takes it down into southern Canada and eventually into the United States.
Let's begin with the anatomy of the jet stream. A jet stream is a channel or river of fast-flowing air in the upper atmosphere created by the sudden change in vertical temperatures. The natural spin of the Earth and the difference between cold and warm air creates tongues within the jet stream. A tongue of warm air that migrates northward is called a ridge. A tongue of cold air is called a trough that migrates southward. Normally in winter, the jet stream is extremely strong and highly organized due to the lack of solar influence. Warming of the upper atmosphere causes the jet stream to become weaker, thus allowing tongues of cold air to plunge toward the southern reaches of the mid-latitudes. At the same time, warmer air shoots toward the polar region.
One of the things that has been noticed is that when there's a sudden warming in the stratosphere, and they call it sudden stratospheric warming, when an event like that happens, and we take measurements throughout the vertical structure of the atmosphere, but when that occurs, typically within maybe 10 days to 2 weeks after this sudden stratospheric warming, that polar vortex begins to drift south.
What is typically misunderstood about these events is that people continue to be skeptical about global climate change. In fact, while we were experiencing winter's wrath here in the States, a ridge of warmer air was shooting towards the polar region. In some cases, weather stations in the Arctic region were recording warmer temperatures than central Illinois.
So we've had, the winter's over as of yesterday officially, but we've had one of the coldest winters probably in the last 20 years.
Minimum temperatures here in Charleston dropped to negative 27 on January 19, 1994. That record-breaking temperature was possibly due to a weaker jet stream, allowing the polar vortex to plunge to the south. Not only did central Illinois see near record-breaking temperatures, but cold temperatures coupled with passing storm systems due to an active jet stream brought record snowfall to the region.
Snowfall amounts, if you look at December, January, and February collectively, probably about maybe twice what was called the average for that 3-month period. And that's significant. It's caused people to get pretty disgusted.
As we continue to move toward the middle of the spring season, and with the jet stream continuing to be active, the threat of an active storm season looms across the region. Unlike the winter and spring of 2012 and 2013, we can expect a significant share of severe weather while tongues of cold air and warm air continue to trade places. We're always looking for weather questions and weather stories. Send yours to weiu@weiu.net.
We hope you've enjoyed our first presentation of Illinois Skies.
As professors of geography, we enjoy educating future generations of Illinoisans in the classroom.
And beyond the classroom, about the fascinating wonders of Illinois' landscape.
Until we see you next time, look up and reflect on the beauty of Illinois skies.
The Eastern Illinois University Department of Geology-Geography is a proud sponsor of Illinois Skies and provides integrative learning opportunities for students and the community to explore the physical and cultural world near and far.